Hey everyone, what we are talking about for this lesson is probability, and we have the classics for probability from every math course that ever dealt with probability. We've got some playing cards, we've got some dice, we've got a coin, and we've got the good old-fashioned bag of objects. All right, so you can kind of tell that I have 20 golf balls in this bag, and I made it clear so you can see. Now, obviously, with the probability problems, you can't see inside the bag, but I just kind of wanted to show you all of the possibilities inside of this. So with probability, there's something called a sample space. And a sample space is everything that can happen. So let's kind of go through kind of the simple ones here. When you're looking at an event is kind of like, this is the thing that's going to take place. So if you flip a coin as the event, the sample space, everything that could happen, you could get heads or you could get tails. All right, so that is the sample space, heads or tails, for flipping a coin. When you are rolling the dice, all right, or if you talk about dice, we look at a singular die, but if you notice in a lot of math books, they talk about a numbered cube. All right, cube having 6 sides, numbered 1 through 6. All right, so the event of rolling one die has a sample space of 1, 2, 3, 4, 5, and 6. So that would be the sample space, the numbers 1 through 6. A deck of cards, all right, if you look at a deck of cards, that has a huge sample space. I'm not going to go through every single one of them. But when you're looking at a deck of cards, most people understand the deck of cards if you've ever played games when you were a kid or whatnot. There are 4 different suits, and there are 13 cards in each suit, ace up through king. And that makes for 52 total cards. So since there are 52, that's why I'm not going to go through all of them. But ace through king in diamonds, ace through king in spades, ace through king in clubs, and ace through king in hearts. All right, so that would kind of be the sample space. Like I said, I'm not going to list all of them. And then if you're looking at the good old bag of objects, all right, the sample space here, if you look at it, there are 20 different golf balls in here, but there are really only 2 things that could happen. You can pull out a white golf ball, or you could pull out a pink golf ball. That would be it. So that would be considered the sample space. So it's important to be able to identify the sample space when you're looking at finding the probability, when looking at all of the possible outcomes. So taking a look at some of the problems you're going to see on ALEKS, the first one kind of talks about the sample space, first couple. And instead of dice, obviously, like I mentioned, they call them a number cube with the 6 faces labeled 1 through 6. So the sample space, as we talked about before, are all of the numbers that are on that cube. So we've got, I need to bring my marker up here. So we've got 1, and then want us to separate them with a comma, 2, 3, 4, 5, and 6. Now you have to look at the actual event, in this case, of rolling a number less than 5. All right, so you have to know your inequality words. When it says less than 5, it does not include 5 because 5 is equal to 5, not less than. So 1 is less than 5, so is 2, 3, and 4, and that is it. All right, so looking at the sample space, 1 through 6 is everything that can happen, and then the specific event of rolling something less than 5 gives us 1, 2, 3, and 4. All right, let's move on to another question here. All right, so the timeless spinner problem, I forgot to mention that one. The spinner problem, so it says that there are 6 equally sized slices shown below, so everything has an equal chance of going. So now we want to find the probability that it's going to stop on the white slice. All right, so to find probability here, what we have to look at is kind of the entire sample space is what we are going to take this out of. All right, so the entire sample space is the 6 different things. And I'll tell you what, I think a better way to think about this is the total number of outcomes. All right, so if we think of the sample space as we can land on white, we can land on gray, we can land on black, but out of that sample space, there are 6 things that could happen here. So in this probability problem, the total number of outcomes is 6. Now, the last problem talked about an event occurring. So in the numerator, we have ways the desired event can happen. So in this particular problem, they have what is the probability it'll stop on a white slice. So on this, there are 3 different white slices. So we have 3 ways that the desired event can happen, and we have 6 total outcomes. Now they want us to put this fraction in simplest form, so this would just end up being 1/2 for this problem. So I'm going to go ahead and put in that fraction 1/2. And we'll move on to the next problem. So another spinner, this time we have 10 equally sized spaces, and they want the probability that it's going to stop on a gray slice. So when we look at this, I see 2 gray slices, and out of the 10 total slices, I didn't have to count all the slices up because they told us there were 10 of them. But this is not in simplest form. So we need to make this, divide both of them by 2, make it 1/5. All right, so this is simple probability because it's pretty simple here. Here's the items in a bag. So they give us the see-through bag, 6 total marbles in here, and they want to know what's the probability that it's going to be gray. Well, I see 2 out of the 6 marbles, and in my head I know that that simplifies to 1/3. So now we've got a box that contains 10 cards. So once again, we know it's going to be out of 10, and they want to know what's the probability of us choosing a letter from L to Q. So I'm going to mark some things up here. So L to Q, all right, so from L all the way over to Q, I want to count how many things there are here. So I've got 1, 2, 3, 4, 5, 6. All right, so I've got 6 out of 10, which we're going to divide by 2, simplifies to 3/5 here. All right. A 12-sided die this time. So we've got a dodecagon here. For those people wondering what a 12-sided die is called. So we've got a dodecagon with sides labeled 1 through 12. Each side is equally likely to be rolled, so it's not an unfair die. So what's the probability of getting a number greater than 10? So we think of the numbers greater than 10. 10 does not count. So we've got just 11 and 12. That's the way that this could happen. So we've got 2 ways out of 12, but as we know, that can be simplified to 1/6. So make sure that you're putting that simplest form in for your answer each time, or Alex will probably yell at you and say, make sure your answer is in simplest form. Same thing here. Box contains 10 cards labeled J through S. They want to know N through Q. So if you just kind of look at it, I see 4 out of those 10, which is going to simplify to 2/5. I don't think we need to spend a lot of time on this problem because we already saw one very similar to it. A couple more here. An organization will give a prize to a local artist. That artist will be randomly chosen from among 3 painters, 7 sculptors, and 12 photographers. So once again, we're looking at the total number of outcomes here. So the total number of outcomes, all right, we have 3 painters, we have 7 sculptors, and we have 12 photographers. So altogether, that is 22 different artists. So now I want to know what's the probability that the artist chosen will be a painter or a sculptor. Well, we have 3 painters and we have 7 sculptors, so that's 10 total people. out of 22. All right, so 10 out of 22, we can simplify that, divide both of these by 2, and we end up with 5 out of 11. So the probability that an artist chosen will be a painter or a sculptor is going to be 5 out of 11. And that one was a little more difficult because they were talking about, you know, distinct items. Not everything was all the same. Like, they're not all cards, they're not all marbles in a bag. So one more question like that before I can turn you loose and you get to work on your own here. Drawers filled with 9 black shirts, 6 white shirts, and 5 gray shirts. So once again, we're gonna have to do a little bit of adding here to figure out the total outcome. So we've got 9 plus 6 plus 5. That's a nice number of 20. Quick reminder of compatible numbers. 6 plus 5 gives me 11. And then 11 and 9 are those compatible numbers that gives us a nice even 20 there. All right, so now the question is, what's the probability that it is not a white shirt? So we have to think of the event of not being white. Well, you could have a gray shirt, which there are 5 of them, or you could have a black shirt, which there are 9 of them. So 14 shirts altogether are not white. Another way to think about it, if they want not white, this is called a complement of an event. So if there are 6 shirts that are not white, that means the rest of them, 6 shirts that are white, that means the rest of them have to be not white. So you could also take 20 minus 6 to end up with that 14. So kind of 2 different ways to arrive at that 14. Either way, you'll get 14 out of 20, and that's going to simplify to 7/10 as our answer here. So I'm going to put that in. That one's obviously going to be correct because we are smart in understanding what is going on with this simple probability. And your assignment, as you can see, is entitled Simple Probability on Alex. There are 10 questions. I shouldn't have circled green on green. There we go. There are 10 questions on this worth 1 point each, so we have a total of 10 points. This is going to be a little bit different. You can watch the video today, but it's not going to be due until next Wednesday. All right, so a little extension here. So you have until next Wednesday to do this one. And then we have just one more math assignment after that to finish out the year. Incredible. I can't believe where the time has gone, but this certainly has been a year to remember. Good luck with this assignment. As always, you can Zoom with me during your class time or during the office hours, or send me an email if it's a simple question. Good luck.